Hello everyone, once again warm greetings to all of you. I hope that all of you are doing excellent in your studies. So today we are going to start the second lecture of chapter 5, electricity grade 9, which is related to the potential difference. So what is potential difference? It is very important in electricity, and let's begin our lesson. So basically let's begin that what causes the electric current. If you see this is if you let's give you an example. Suppose that there are two containers, okay, and these two containers are connected through a pipe. This is a pipe, okay. So between these two containers you have filled these two containers with water. But the level of water in these two containers, it is not same. Is that clear? So what happens that whenever we want to open the flow between these two containers through this pipe, what will happen? The water will flow from high level to the low level. So we can say that there is actually a potential difference between this two level. So there is level of difference here. The level of water in object in this container, the level of water is very high, and in container B the level of water is very low. So definitely the water will flow from container A to container B because the level is very high. So the direction of the flow of water will be from A to B because the level of water is very high, greater over here. In the same case, we can say that actually there is a potential difference. Potential means storing something. So the storage of water in A is much greater as compared to B. So we can say that there is a difference in the storage of water between these two containers. Is that clear? So in order to in the same case that if we want to have a flow of electric current, we should have a difference in the level of the electric charge between 2 points. I repeat that in order to have electric current, in order to have the flow of current, we need to have a difference in the level of the electric charge at two specific points. If we do not have the difference in the level of electric charge, electric current will not flow. So it is the level of water that decides the direction of water flow from one tank to another, and not the amount of water present in them. Also, water flow ceases when the level of water in both the tanks is equal. So definitely that if we do not disconnect the flow of water between these two containers, what will happen? That the water will flow from container A to container B until and unless both the level will become equal. So when the level in both the containers equalize, the flow of water will stop. In the same case, that if we want to have electric current, the electric current will stop if the level of charge at two different points, they are same. Similarly, in electric conductor, the electric charge flows from one end to another end of the conductor only when electric potential difference exists between two of the conductor. So if the potential difference, if the change in the level of the charge, they are different at 2 points in the conductor, we can say that the electric current will start moving. Thus, an electric potential difference is the condition required for a conductor to have an electric charge traveling through it from one end to another and is measured in volts. So the unit for measuring the electric potential difference is volt. If the potential difference across two ends of a conductor is 0, there exists no electric current through the conductor. Or in other words, if we say that the electric charge present at two different points, the level of electric charge at two different points, if they are same, then no current will start moving. Initially, it was considered that the flow of positive charge constituted an electric current. Initially, when people were less aware of the electricity, they considered that actually the electricity is actually the flow of positive charges. Later it was discovered that it is not the movement of positive charge that causes electric current, but the flow of electrons that causes electric current in a conductor. So now we know that actually the electrons, they move, so the electric current occurs. So we can usually say that one type of electric current is a flow of charge from a body at a high potential to a body at low potential, as assumed before, and it is called conventional current. In past, people used to think that electric current is actually the flow of positive charge, and they call this current as conventional electric current. But nowadays, what we are observing nowadays is that electric current is actually the current which is due to the movement of negative charges from a negatively charged body to a positively charged body, and we call this electronic current. Okay, so basically that electric current that nowadays you are observing, it is basically electronic current, not conventional current. So let's come to the main point, that potential difference. Electrically, potential difference can be defined, potential difference between 2 points in electric field is defined as the work done in moving a unit positive charge between the 2 points in the electric field against direction. So, or it is the amount of energy required to move a charge between 2 points in the electric field against its direction. Why work done is required? Because definitely that if we have a if there is level of charges, if there is two point where the charges are at different potential, so definitely we need to do work to maintain the potential difference, or there is a requirement of energy is required to maintain the potential difference between 2 points. Is that clear? So the energy required to maintain the potential difference, or we can say the energy required to move a charge in electric field between 2 points, is called potential difference. And you have to move the charge against its direction. Against direction mean that you have to move the charge from lowest potential to higher potential. Is that clear? Why from lower potential to higher potential? In order to maintain the potential difference. So potential difference is equal to work done required per charge, or it is equal to energy required per unit charge in an electric field to move against its direction. So we can write potential difference is equal to work done per unit charge or energy required per unit charge, and its unit is volt. It's 1 volt is equal to joule per second. Let's do some question. Question number 1. A charge of 10 coulomb is brought from infinity to a point P near a charged body, and in this process 200 joule of work is done. Calculate the electric potential at point P. So we have electric charge which is 10 coulomb, work done is 200 joule, and electric potential we need to find this from the equation of electric potential, which is the work done per unit charge. Putting the value in the formula and doing proper calculation, 200 divided by 10, it comes out to be 20 volt. Question number 2. The electrical potential at a point in an electric field is 6 volt. Find the work done in bringing 12 coulomb of charge from infinity to that point. So you have to find the work done in bringing a 12 coulomb of charge from a distant distant point to a particular point. So there the 6 volt is the electrical potential, and the work done is, you need to find charge is given that it's 12 coulomb. So voltage is equal to work done per unit charge. So work done is equal to product of voltage and charge. Putting the value in the equation and doing multiplication, we get the work done to be 72 joule. Question number 3. How much electrical energy will be the 6 volt battery supply when it drives 2 coulomb around a complete circuit? So how much energy is required for the 6 volt battery to drive a 2 coulomb of charge around a complete circuit? So volt is given, charge is also given. You need to find the energy required in moving charge of 6 volt. So arranging the equation of the voltage, the energy, we know that voltage is equal to energy required per unit charge. So energy is equal to product of voltage multiplied by charge. Putting the value in the equation and doing calculation, we get the energy required is 12 joule. So I hope that you have understood the lesson. Do study and practice the question, and take care of yourself.